Welcome to the Azure Synapse Analytics On-Demand session. My name is Mariya Ali, and I'm going to be walking you through some highly sought-after features that we've worked hard to bring to you this summer. But first, let's do a quick recap on what's available in Azure Synapse Analytics today. Enterprise data warehousing has been the cornerstone of business analytics for decades and remains one of the most business-critical workloads for customers. The data warehousing capabilities in Synapse are built on Microsoft SQL Engine, which includes comprehensive support for industry-standard SQL language, as well as structured and semi-structured data. The SQL Engine also has broad support by a variety of ISVs for workloads such as data integration, data visualization, data science, as well as data modeling applications. Fine-grained security enables easy democratization of data across an entire enterprise by applying security directly at the data layer itself, instead of using a unique secure view for each policy. Let's get into the latest and greatest that Azure Synapse Analytics is releasing in the upcoming quarter. We have features that will help query performance by improving data distribution, make your migration process easier, and improve your security posture. Let's start with data distribution features. Azure Synapse Analytics architecture includes a control node and one or multiple compute nodes. Each table's data is distributed into 60 distribution databases across the compute nodes. The Synapse engine creates a query plan that executes in each distribution database. A query plan includes execution steps and data movement operations. Data move operations allow the data to be moved between compute nodes so that query execution steps can execute on each compute node independently. Synapse SQL supports three types of distributions. Hash distribution improves query performance on large fact tables. Round-robin distribution is useful for improving loading speed. Replicate distribution replicates small tables across all the compute nodes. A table's data distribution method is set at table creation time and cannot be changed without dropping or recreating the table. A well-designed distribution method can improve query performance of your overall workload, reduce expensive data movements, and slow down having skewed data. Now that we have refreshed your memory on the types of distribution strategies that are available, let's help you find one that is most appropriate for your workloads. This is where Distribution Advisor comes in. Distribution Advisor is a recommendation system that analyzes chosen queries or past-run query data to provide suggestions on data distribution, which can improve performance. Consider these queries where the customer is trying to collect sales data by product based on location. Getting product sales data is crucial for this customer, as is their coffee, and these queries are running slow. The customer decides to run the advisor, and it suggests changing the distribution column to product from date of sale. This change reduces the movement needed to execute the query and improves performance. Distribution Advisor can analyze up to 100 queries to recommend distribution strategies. All the hash tables that we have discussed so far distribute on a single column. When table size grows larger and query complexity increases, queries start to run slower due to heavy data skew or data movements. This summer, we're targeting to release the support of multi-column distribution for public preview. Multi-column distribution allows customers to hash distribute Synapse SQL tables on up to 8 distribution columns. It delivers a more even distribution of table data, reduces data skew over time, and improves query performance. Adding this feature to Synapse will also simplify customers' migration from other platforms that allow multi-column distribution tables. Consider this example where a table is distributed on product key. The choice of this distribution column is causing skew and causing queries to slow down while waiting for results from some distributions. By using the new multi-column distribution feature, when the table is distributed on product key and region key, data distribution is more balanced and queries run faster. Another feature we're excited to announce that will soon be generally available is merge. Public preview customers of merge will know this tsql command as a simplified way to capture all your insert, update, and delete operations within a single statement. Users will no longer need to tease apart old code into separate statements, making migrations a breeze. Today, we will show you a common scenario for merge where I need to sync a working dimension table based on new information in an updated source dimension table. For this demo, I will be using the New York taxicab dataset. Specifically, I will be looking at the Hackney license dimension table. In New York, a specific type of license is required to drive a taxi. This license is called a Hackney license. And in our dataset, we use the Hackney license dimension table to keep a mapping of Hackney license IDs and the actual Hackney license codes that correspond to it. This way, in our trip table, we only log the Hackney license ID. If we ever need to find the code for the driver that the Hackney license ID corresponds to, we often end up joining these two tables together. Let's say every day New York gets a source of newly updated drivers. In this example, we'll need to sync our existing working Hackney license dimension table with the new table so that we accurately track drivers. We'll show how easy this is with merge and then compare to the old workaround of using manual inserts, updates, and deletes. I have created two tables, Hackney license prod, which is our target table, and Hackney license new, which needs to sync to the prod table. You can take note that this new table has two new license drivers, one updated license. Perhaps the license code was incorrectly inserted the first time around, and 3 deleted licenses. These driver licenses have probably just expired. With merge, let's set prod as our target table and the new as our source table. Here we use the merge command to insert into the target table for all rows that exist in the source table, but not yet in the target. Then we tell merge that when both target and source share a license ID, but the other values in the row differ from source, let's update the row in target with source's values. In this case, perhaps, the initial license codes were incorrectly recorded, so we need to update to the correct values. Lastly, we tell merge to delete all the rows from the target when the license ID doesn't exist in source. With this action, we're removing all the recently expired licenses from our working table. Now, if we check the two tables again, looking at IDs greater than 42954, we see both tables are completely in sync. If we wanted to do this merge without using the actual merge command, we would require 3 separate statements based on subqueries, inner joins, and left-outer joins. Let's see how tedious this workaround is. We're starting with the original out-of-sync tables. First, we have to insert into the target prod table based on a subquery that identifies new rows in the source. Next, we have to update the target prod table using an inner join and identifying common license IDs with different B key and code values. Finally, we have to use a left-outer join to find rows in target with the ID values that don't exist in the new source and remove them from the target. Again, we can verify that both paths have put the tables into consistent state. But our roundabout method on the second try forced us to execute 3 separate statements with redundant logic that is already built into the merge statement. Today, we've shown the beauty of the merge statement in Azure Synapse Analytics. With a single command, make decisions on updating, inserting to, and deleting from one table based on another, facilitating migrations, and simplifying usability. We hope you give merge a try. We are excited to announce the release of cross-subscription restore. This has been one of our top requested features as it unlocks multiple scenarios from dev test to simplified billing at subscription level for restored data warehouses. Customers can leverage this feature whether they want to restore a standalone dedicated SQL pool or a dedicated SQL pool in a Synapse Workspace. Let's look at how we can make the database available to another department in a separate subscription so that they can scale independently and have a clean billing delineation to their cost center. Here is an Azure automation account with a runbook that performs a daily restore to a second subscription from the original. This would typically run after daily loads are complete. Cross-subscription restore is made available in PowerShell with az.sql module and version 3.8 or higher. So we review the installed modules to ensure that we have the right version. We will review the script to highlight some of the key commandlets. After setting our variables with the source and destination details, we log in with the managed identity of Azure Automation account. Here, we will create a user-defined restore point at the point in time the runbook is executed. Then, we will get the source SQL pool and the latest restore point that we just created and store them in variables. The difference when performing a cross-subscription restore from a normal restore is to change the AZ context to the destination subscription prior to calling the restore commandlet. After deleting the database, if it already exists in the destination subscription, perform the restore using the original database's restore point in time and original database's resource ID. This runbook is executed daily, keeping our other departments' SQL pool refreshed in their own subscription. We can navigate to the other subscription resource group and see that the SQL pool has been restored and online ready for requests. One thing to note in this process, although the source SQL pool can either originate from a Synapse Workspace or a standalone server, the destination is a logical standalone server. This will be fine when consuming from SSMS, Power BI, or other IDEs. However, if you want to have an integrated Synapse Workspace experience, you would have to perform one more restore step in the destination subscription to place an existing Synapse Workspace of your choice. Further details on this, as well as the end-to-end PowerShell example, can be found on the Synapse blog post regarding this feature. Column-level encryption helps customers implement fine-grained protection of sensitive data within a table. With column-level encryption, customers gain the ability to use different protection keys for columns in a table, with each key having its own access permissions. The data in CLE, in forced columns, is encrypted on disk and remains encrypted in memory until the decrypt by key function is used to decrypt it. Thank you for watching this session. We hope you give these features a try. Enjoy build!